So this question is on escape velocity. I had prepared a video a few days back on escape velocity. I hope you have looked at it. This question is based on deciding the factors on which the escape velocity depends. So let's see what are the factors: the mass, the direction of the projection, the height. So if you have a body which wants to escape Earth, generally the formula of escape velocity, V escape, just remember a shortcut is given by 894 by under root of R kilometer per second. Okay. And the R is the distance of the body. Distance of the body from the center of the earth, right? So this is a shortcut. Just memorize this, okay? In your entrance examination or school examination, you can straight away memorize this if you get a numerical. If you see this question, there is no mass mentioned, in the formula. If you see, okay, so the mass of the body, answer is no, it does not. So the answer to A is no, it does not depend on mass, because if you see this formula, there is no mention of mass. It's only distance of the body from the center. The location from where it is projected. So if you talk about, all right, so I want to pay special attention to part B of this problem. Now, if you see, when it comes to location, if I were to draw the diagram of Earth, the way it is drawn is this, okay? Generally, the satellites are launched near the equator, okay, eastward. So it is, so location matters, and if you launch the satellite near the equator, it helps. The reason is the equator, okay, the equator has a speed of around 1670 kilometers per hour. Okay, so Earth is rotating, but the poles, for example, if you consider a piece of mass near the poles, okay, this is rotating with less velocity. Okay, so less speed is available here. So most of the satellites are launched tangentially so that they get an extra velocity of 1670 kilometer per hour. Okay. See, our final aim is that the satellite is able to escape the Earth. But the way it is done is first the satellite has to be put in orbits. So after it is put in orbits, after that only the satellite is released for escape. So equator is having a speed of 1670 kilometer per hour. So all the landmass which is close to equator is moving faster as compared to the mass at the pole. I hope this is making sense. And therefore, the initial velocity which is granted by the rotation of Earth adds to the initial velocity of the satellite. So whatever initial velocity you provide to satellite, there is an extra velocity that comes from rotation in the eastward direction. Okay. Therefore, the location matters because it helps you put the satellite faster in an orbit, and then using the multi-stage rocket propulsion in multiple stages, the velocity is increased and the orbital size goes on increasing, and finally the satellite is launched. I hope this made sense. So we can say that the location is important. A bit complicated, but it is beyond our course. This topic is called as orbital mechanics. It is not in our course, but we still should be able to understand that Earth is rotating and the rotation near the equator is very fast. That rotation gets added to the initial velocity of the satellite or the body to be launched. Thank you. The direction. So if you see this formula, there is no mention of direction in this. So the answer to this is no. Next is the height of the location from where the body is launched. So the answer to this is yes, because if you see, if you have Earth, the surface of the Earth here, and the body is at, for example, the body is launched, from Mount Everest, which is 9 kilometers above the surface of the Earth. So if you calculate V escape, at a height of 9 kilometers, which is the height of Mount Everest, and radius you consider as 6378 plus 9, you will get a slightly less amount of escape velocity, right? So escape velocity is definitely dependent on the height at which you launch it,